In the word problems, again, our goal is to read the problem, use what we learn to create, in this case, or in this instance, a triangle. And when we create that triangle, we're going to be able to use our law of sines, law of cosines. If it's a right triangle, again, you can use Pythagorean theorem and SOHCAHTOA. So read the problem first. Get the gist of it. Don't try to get the picture down before you read through the problem. Read the problem first, and then you can come back and then put the pieces in that you need and then start filling them in. In the first 3 problems, sort of the basic drawing is already set out for you. You can be as fancy in your drawing as you want to, or as primitive as you want to. So this problem has a boat sailing due east, parallel to the shoreline at a speed of 20 miles per hour. At a given time, the bearing to a lighthouse is south 68 degrees east, and 30 minutes later, the bearing is south 52 degrees east. Find the distance from the boat to the lighthouse at boat position 2. So on this one, it's a pretty primitive picture. We have boat position 1 as a dot, boat position 2 as a dot. Probably if I were drawing this, I would just write 1 and 2. I wouldn't even go with boat position on it. So it can be, like I said, pretty primitive picture. But boat position 1 and boat position 2, that's the same boat traveling. What we're interested in is the distance that the boat is from position 2 to the lighthouse. That's what the question asked. Find the distance from the boat to the lighthouse at boat position 2. So that's my unknown. Put whatever variable in you want. They talk about the line of sight or the bearing. They talk about the bearing, which is kind of the line of sight. And they give it to us in sort of a funny way. That south 68 degrees east. So it requires a little bit of knowledge in terms of north, south, east, west. And so remember that it's north, south, west, east. I say north, south, east, west, but west is on the left, east is on the right. So if we're talking about the bearing to the lighthouse at position 1 being south 68 degrees east. That means if the person in the boat looked directly south, it would take a movement of his or her head of 68 degrees to get the line of sight to the lighthouse. And I get it that that angle is on the outside of the triangle, but we'll be able to do some work and do some figuring to use that to our advantage, okay? But if I am the boat looking south, it takes a movement of my head 68 degrees in the easterly direction in order to see the lighthouse that I'm looking at. So let's use that same concept for boat position 2, because boat positions 2's bearings is south 52 degrees east. So from boat 2, again, if we were looking directly south, it would take a 52 degree movement of the head to get to that line of sight. And again, it's a little bit better than the first angle. The first angle is not even in the triangle. At least the second angle is in the triangle. But regardless, I'm going to need to figure out some more information so that I can fill in the missing pieces. One thing I do know, though, is if I'm looking at my direction, the south to east total movement, if I'm looking south to directly east, it's a 90 degree movement. Okay, so I do know that this angle right here is 90 degrees, which means I'm looking at a complement. And like I said, this brings back some of our geometry days. Complement is two angles that add to be 90 degrees. So I know my missing angle here has to be 22 degrees. Because 90 minus 68 is 22. Agreed? Good. Okay. I also know that on the other side, if I were going to be looking south to directly west, I would also have a 90-degree angle. How does that help me with that side of it? Is that enough for me to find this whole thing? Yeah, what is it? 142. Great. Excellent. All right, so I've got two angles in the triangle, and I know what I'm looking for. I'm looking for that far on the right side from boat position 2 down to the lighthouse. At this point, I feel like I just don't have enough information. What am I missing? What detail didn't I touch on in this picture? They give us, yeah, Johnny. And position 1 to position 2, they don't even straight out give us the distance, do they? They make us do a little bit of work. They say the boat is sailing due east at a speed of 20 miles per hour. So if I'm driving or sailing 20 miles per hour, for how long? 30 minutes, which is how much of an hour? A half hour. So I'm going for a half hour. I will be 10 miles down the road. So I'm traveling 20 miles an hour for a half an hour. Half hour is 30 minutes. It's measured in miles per hour, so I have to put that in terms of hours. So I traveled 10 miles. All right, so I am in pretty good shape now. I just have to decide which one, law of sines, law of cosines. It's not a right triangle, so I can't use SOHCAHTOA and I can't use Pythagorean theorem. Which one do I have the information to solve, or can I easily get the information to solve? Yep. Law of sines. I'm missing one thing though, right? But it's a pretty easy thing to find. What am I missing? The third angle. So this third angle here, I'm going to have to figure out three angles in a triangle, 180 minus 142 minus 22. And what'd you get? 38? 36? Oh, 16. Holy cow. Open my ears. 16 degrees is what we get. Good. Okay. So now I can set this up and solve. And again, this is where I'm going to let you guys do the math. I can put the sine of 16 over 10 equals the sine of 22 over x, because I'll take the sign opposite the x, cross multiply and solve. I'm going to get a rough estimate. It doesn't really tell us what to round to. Let's just go to the 10th so we can keep it consistent in our stuff. And again, I'll wait for an answer and some concurrence, and then we'll... I got thumbs up. So 13.6 and miles. Okay. Problem number 2 is another one. I think these are problems that you've done kind of in geometry often, where you have the light pole and the shadow. So in this particular problem, my light pole's not standing straight up. It's sort of tipped a little bit. And in fact, from vertical, it's tipped 8 degrees. So a pole tilts towards the sun at an 8-degree angle from the vertical, and I think that's supposed to say, and it casts a 22-foot shadow. The angle of elevation from the shadow to the top of the pole is 43 degrees. How tall is the pole? And so we'll get that whole setup in here. What I'm looking for is the height of the pole. That's my unknown. Not the straight distance from the ground up to the top of the pole, but the actual length of the pole. How tall is the pole? And that pole casts a shadow. And they said that shadow is 22 feet. And that shadow has an angle of elevation up to the top of the pole. So that angle of elevation, if the shadow had eyes, it would be many degrees would it have to look up in order to see the top of the pole? And that would be the 43 degrees. 43, was it? Am I remembering right? Okay. Yep, 43 degrees. And then that one little detail that it gave me, if this pole was standing straight up, this would be an 8-degree tip that we have there. If it was standing straight up, it would be a right angle. So the total angle would be 98 degrees. So again, it looks like I'm in the same situation that I was before, where I can do the law of sines. I'm just missing an angle. So I'll do 180 minus 98 minus 43, and I'll get that top angle. And what is that top angle? $39. And I need that y because that's the angle across from the length I know. In fact, from the only length I know. So then I can set up my law of sines. The sine of 39 over 22 equals the sine of 43 over the unknown length of the pole. And again, I cross multiply and solve. And again, I'll wait for some answer concurrence. So 23.8, we're talking about feet. And let's move on. So far, the first two have been law of sines. Our next one will be a setup for law of cosines. Just because I want you to know that it can be any of them. You can use law of sines, law of cosines. You have to look and see what's given in the picture. I always try law of sines first if I can. Remember, as nice and easy as law of sines is, it has its issues. We have the ambiguous case that we talked about the last time we were together, that it could create two triangles, so I have to be a little bit careful. And the other thing is you can't always use it. You don't always have enough information to use it. So in this problem, we have a baseball player in center field, and he's playing approximately 330 feet from the television camera that's behind home plate. A batter hit a fly ball that goes to the wall that is 420 feet from the camera. Approximate the number of feet the center fielder had to run to make a catch if the camera turned 9 degrees in the following the play. Right, so we have our picture here. I've got my center fielder, I've got his final position, got the camera, and I've got the distance from the camera to the final position. So I connected my points. I need you guys to help me fill this in. What do I know? What can I fill in? What information do I have? Go ahead, Kenzie. So we've got this guy, 330 feet, super. $420. Okay. 420 feet. Yeah, so the camera facing the center fielder and then watching the center fielder sort of run over to where the ball ran makes a 9-degree angle, right? That'd be that guy there. Now, when I get a scenario like this, a side angle side scenario, we've talked about that before, where I have two sides and an included angle, side, that setup always screams law of cosines. Because I don't have another angle, so I can't find a third angle. And the side I want is across from the angle I know. So I'll call that X because we want to know how far he ran. And so again, it's just going to be a matter of setting this up. So I'm going to set it up using my law of cosines. The side I'm looking for is equal to, that side squared, I should say, is equal to 330 squared plus 420 squared minus 2 times 330 times 420 times the cosine of 9. Remember, when you have this and you're just looking for that single value on the other side, you can just plug it all in your calculator at once. If you're solving for the angle, different story. Remember, you have to follow the algebra. Don't forget, once you plug it all in, you've got to do the square root. And again, I'll just sort of wait for some answers. 100, 107.3, and that's feet. Do I get some concurrence on that too? Yep, okay. Some head nods. All right, so our next ones, we're actually going to be in charge of drawing. And again, at this point, we can do one, we can do two, we can do all three or whatever. But let's just start with, I want to just go on to the next, let me see. What do I have on this one? Juan and Ramella, seashore. Yeah, we can do that one. So Juan and Ramella are standing at the seashore 10 miles apart. The coastline is a straight line between them so that they can see the same ship in the water. The angle between the coastline and the line between the ship and Juan is 35 degrees. The angle between the coastline and the line between the ship and Ramella is 45 degrees. How far is Juan from the ship? So even though they don't have the picture drawn for me, I do have 3 pieces of information. I've got Juan, I've got Ramella, and I've got a ship. So I will do Juan and Ramella along that seashore. And I'll put the ship down here. Notice I didn't get very creative. If you feel like drawing, some people draw the pictures. Draw a ship, draw a person for Juan, draw a person for Ramella. Whatever you want to do, however much energy you want to put into it. Depends on the day. Sometimes I get fancier than other days. Today I'm just using the letters. So the one thing I do know is Juan and Ramella are 10 miles apart. The next part gets a little tricky, so I have to read carefully. It says the angle between the coastline and the line between the ship and Juan is 35 degrees. Angle between the coastline and the line between the ship and Juan is 35 degrees. So would that be the upper left angle, upper right angle, or bottom angle on my picture? Upper left, yep. And then they go through the next one that says the angle between the coastline and the line between the ship and Ramella is 45 degrees. And so that's going to give me that angle over there by Ramella. I'm looking for Juan's distance. This is another setup that screams law of sines. I just have to find the missing angle. I did the math in my head and I think I got 100 degrees. Yeah? Okay. So then I will do the sine of 100 over 10 equals the sine of, I'm looking for Ramella, so I have to use, or sorry, I'm looking for the distance between Juan and the ship, so I'll have to use the angle by Ramella. So don't just think because we're talking about Juan, we're going to use Juan's angle. We have to use the angle across from it. So I'll do the sine of 45 over x, do my cross multiplying and solving. Sometimes your calculators are going to give you funny answers when you do the solving on this problem. It depends on the kind of calculator you have, and that's because the sine of 45 is one of our families. 45 degrees is pi over 4, so the sine of 45 is the same as pi over 4, which is the square root of 2 over 2. And if you have a certain kind of calculator, it's going to keep the square root of 2 in your answer. You might have to hit a key or two to get it to an exact answer. If you don't have that kind of calculator, no worries. It's just going to give you a decimal right away. And in fact, it looks like some of you have already gotten that decimal. How far is 1? 17.2 is what I think I... Say it again. 7.2, sorry. 7.2 miles. Okay. Sometimes it's hard to hear through the... Can you guys hear me through this? Yeah, okay. All right. So do you guys want to see one more? Should we do one more? Get us going? Or you feel pretty decent? One more? None more? I'm seeing heads shaking. No more. You feel good? Okay. So then you guys can go ahead and work on your homework. If you finish your homework, feel free to put it in the basket. If you want to hold on to it until the end, that's fine as well. For those of you watching the video, I am going to work through 5 and 6 without talking. And so you can just kind of work through and check your answers as you go.